Welcome back everyone to another video. We're back with the ShibaSoku side quest. We need to get this thing finished because I am over it. All the capacitors have arrived and we are going to start replacing them. And how many capacitors do we have to change? A lot of capacitors, and I am not looking forward to this job. There is a lot to do. Most of the electrolytics we're going to be changing to Panasonic brand, except for the power supply, which we've had to go with some Vishay capacitors because of their large size. We had to try and get axial stuff. There's some Cornell Dubilier, however the hell you say it, films to replace those paper and oil capacitors. And all of the film capacitors will be replaced with TDK Epcos capacitors because I've had really good success with their capacitors in the past. So I'm just going to stick with what works. All the bipolars are going to be changed to, well, everything is going to be radial instead of axial, basically, but especially the bipolars, because I found that radial capacitors are much more advanced than axial designs. The axial designs are sort of older generation capacitors, so we're just converting everything to radial, even though it's not an ideal situation. Except for the power supply, we've got axials for those because of space limitations and the weight of these things, and there's other considerations. I don't know what sort of format we'll do this video in because it's going to get really repetitive, just doing board after board after board with time lapses of recapping. So we might do the first one and then we'll just sort of jump ahead and we'll look over the boards as they're finished or something. I don't know. We'll just wing this and let's just get stuck into this thing, okay? Okay, so a quick look at the first input board. This is channel A, I believe. So yeah, we're changing all the electrolytics, all these blue rectangular films. The only challenge that we're going to have with all these boards is they are a two-sided PCB, so they have plated through holes for all of the soldering, and it can be quite challenging to remove all the solder and get these leads out of the PCB. So you're definitely going to see me struggling a little bit with my solder sucker. Luckily I do have an inductive soldering iron, so it has no trouble heating these boards, but getting all that old solder out and getting these components removed can be a bit of a challenge. So yeah, it's going to be fun. We have an LCR meter on standby for testing some of the caps we pull out, and I tend to pre-organize per board because there's a variety of different values, and that way I don't have to go digging through bags every 5 seconds looking for capacitors I need. But anyway, let's get this one started. Now I just wanted to stop the time lapse for a second just to show you the first capacitor we pulled out. This is a 1 microfarad film, and we can see the residue that is on the PCB. This is leaked out of the capacitor. I don't know what it is, if it's glue or some sort of an electrolyte, but they're supposed to be metallized capacitors. It's really weird. I don't know if it's conductive or corrosive or whatever, but this is another reason we are changing all these capacitors. Not only are they cracking and splitting, they're also leaking onto the PCB. So just thought I'd show you that once because it's going to be a theme, I think, on pretty much all of the ones we pull out. And let's just get back to that time lapse. Okay, so this board is all done. Looking really good considering we had to swap all the capacitors to radial design. The capacitor carnage was interesting. We have 2 capacitors that were fine, testing fine. These are all questionable. with a high ESR, higher than I would expect and compared to what we were putting in there. This 2.2 microfarad bipolar that has flown completely under my radar to this point is completely dead. It has a crazy impedance and it has no capacitance. In fact, it does not even pick up on my normal ESR meter. So I'm glad I've got this LCR meter to back me up on those. These films are testing fine, but obviously they're crap and they're leaking and they're cracked. So I don't know if they're actually still okay or if there's something wrong with them that we just can't really measure in a standard capacitor test. Now these little guys are interesting. These are 10 microfarad caps at 25 volts, not bipolar. They're running around 2 ohms ESR on all of them. And the Panasonic FRs we're putting in to replace them are around 0.29 ohms. So big difference. And these caps make up the bulk of the capacitors we have to change for one standard value. They are on every board pretty much. And I'm glad we're getting rid of those because I think the ESR is too high for 10 microfarads. So yeah, this board's done. I'll put in a little bit of B-roll just showing you around, but we are on to the next board. All right, channel B, board 2 is all done. Decided to do this one off camera because it's basically the same as the last one. Interesting little collection here. 3 bipolar Nichicons were bad. One was completely dead like the other board. These 2 had like a really high ESR, like around 9 ohms and 7 ohms. Usual films leaking everywhere. These ones were sort of in the middle, around 2 ohms ESR, not great, not dead. These 2 were perfect. And yeah, I'm just sort of double checking my work. What I generally do is I double check all my polarized electrolytics, make sure I haven't stuffed up and put one backwards by accident, and just making sure that all the through holes have solder coming through the other side. And just gave the board a bit of a wash and checked all my soldering. Everything looks perfect. So another board back in, ready to go. Okay, board number 3 is done. Getting a little bit quicker now. Most of the caps were pretty good on this. The bipolar was excellent. It had a very low ESR. So that tells me now that these generally would have a pretty low ESR, but most of them have been cooked to death. This one sits right down the bottom of the board, so it's been spared most of the abuse. Some of these are getting up to like 3 ohms ESR for these 10 microfarads, which I think is getting high, and these are just leaking everywhere per usual, really bad. I realized my time lapse from the first one was a bit blurry, so I'll try to do another one with one of the boards with the paper and oil capacitors because I think they're the more interesting ones. But yeah, on to the next board. Okay, board number 4 is done. I've already put it back in, and one of the most amazing things about this unit compared to restoring amps and whatnot is how we can just throw the boards back in as I repair them and see how this unit reacts or changes. And board number 4 has fixed the voltage issue. We have 5 volts out on the internal oscillator and we're reading 5 volts now. No more of that garbage that was happening before. We turn on balanced and it jumps up to about 10 volts. A little bit of a tweak maybe. I need to check that with a multimeter. What was responsible most likely is all these Nichicon bipolars are dead on this board, completely dead. Getting a bit of a theme here, which is amazing because I don't usually see Nichicons fail, and normally it's the Matsushitas that fail, and it's the other way around in this board. Film's leaking everywhere per usual, and these little guys, you know, the ESR was over 2. But we fixed another fault, and this unit is just slowly coming back to life or returning to like a consistent low reading, which I'm really happy with. And yeah, it's just great to see. Normally, I do not have this much luck with recapping something to actually fix faults. A lot of people say, you know, recap everything vintage. A lot of the times, the caps are fine, like 99% of the time. This is a really big edge case where a lot of the caps are dead, and this unit must have done a lot of work and had a lot of heat through it. So yeah, let's keep this train going and move on to board 5. Okay, so board number 5 is done. This was probably the most difficult board out of all of them, I would say, because it has this thing added on that's got wires running everywhere, and there was capacitors underneath this unit. So I had to remove this entire assembly to get underneath, which was not fun. I had to put these electrolytic bodges back in. So I've used a bit of glue there to lift them off the PCB. Replaced all the other electrolytics. The paper and oils that used to be here have been replaced with Cornell Dubilier caps. These were about as close as I could get. They're very expensive. They're $12 a piece, which is a lot for that value capacitor. And all the bipolars are changed. So we had 3 completely dead bipolars, an assortment of meh capacitors, and 4 good ones. So the trend of dead capacitors continues, and on to board number 6. Okay, so board A6 is installed again, and we have fixed yet another fault. There was an issue with the phase on this unit where it was sitting at like minus 60, minus 70 degrees, just sort of at a baseline. I didn't mention it because I wasn't sure if it was a fault or if there was something to do with how I had it set up. But we've confirmed now that board A6 is responsible for the phase adjustment, and we are back to basically a 0 baseline, maybe a little bit of a tweak needed. It was 2 Nichicon bipolars again that were completely dead, that were responsible most likely. I think they're in the signal path like the previous couple of boards. Lots of films on that board that were all cracked and leaking, and your usual 10 microfarads that are on basically every board. Yeah, so another win, and we are on to A7 and A8. They're the last 2 boards in sort of the measurement section, and then we've got the 2 over here and the power supply, and we're so close. Well, not that close, but we're getting closer than we were before. I feel like we're on the home stretch. Let's keep going. Okay, board 7 is done. There wasn't a lot of capacitors on this one. There's a few films, 1 bipolar, a few normal electrolytics, and those PIO, paper and oil capacitors again. The bipolar that was in here was completely dead, per usual. One of the paper and oil caps was dead, one was okay. The usual little scattering of 10 microfarads and some more films. All right, we've got one more board left in the measurement section, and then it's onto the power supply and the control section. So board number 8 is done. This is the last measurement board, and the hottest running one from what I can tell. And you want to know the funny part? All the capacitors were alive on it. I mean, there weren't that many anyway, but you can never predict what's alive and what's not just by looking at things. You would think that the hottest areas would have the most dead caps, but those 2 right there were getting blasted with heat, and they're still good. So yeah, I think we'll do the power supply next, and then that just leaves the 2 control boards. All right, here we are with the power supply, all done. I know this doesn't look great, but I am very limited with what I can do here. These are the only sort of axial capacitors I could get my hands on, and they're V-shaped capacitors, and they are quite a bit larger than the originals, but these are also rated for higher temperature, I believe, as well. They're all 105 degree rated capacitors. The top two are Sprague. I offset all the 10 microfarads to the left a little bit so they clear the post when they go back in. And everything's looking good. All the leads are clear. It just doesn't look that great. But you can see why I had to use axials here. If these were radials, there's a lot of weight that would be hanging off the board. And I don't have much vertical room beyond that either. So they just weren't going to work any other way except to use axials. They're very good caps. At the same time, all the ones that were in there were still fine. So this didn't really need to be done, but it's done. So 2 control boards left. We've got to do the backup battery and come up with a holder for it, and we are finished. Okay, so here's the deal. We've got to replace this battery. I can't get anything locally. It's going to take at least a month to get something, which I'm not willing to wait. They're also very expensive, and there are no real easy alternatives to using a NiCad that I can guarantee are going to work. So I am going to use a much larger NiCad battery that I can source locally and should be pretty easy to find for the foreseeable future. It is much larger. It needs a new home. We can't put it on the main board. So I 3D printed a little holder for it, and the battery just literally drops in like that. It will be double-sided taped on 2 different sides, which should give it enough holding power. This tape is very strong, and it is going to mount here and then feed over the top of the boards to that second board where the battery is. And the idea is that the wire will run through and then the cover will go back on top. The only problem is that we have to notch this metal here. I've got to take a reasonable amount out so it can fit underneath the cover. So I'm not looking forward to cutting this, but it's going to have to be done one way or the other. So I'm just sort of covering everything at the moment so I can do that. We're going to notch this out, get this mounted so it's ready to go, and then figure out where the connector is going to go on this main board to replace the battery. So let's get this done. All right, yeah, I was just stuffing rags into the chassis trying to get this thing done, and I just couldn't bring myself to do it because I know metal filings were going to go everywhere, and it was going to be a pain to clean out the chassis again, and I was worried it was going to get inside the connectors and everything, so I decided to just pull this entire inner chassis, which is a lot of work. I didn't want to do this, but it just had to be done. I didn't want to do a half-assed job. So I put it in my milling machine with just this plate, and I've notched it out really nicely with an end mill, and we are looking really good. That is exactly what I wanted. I made the hole a bit larger than the cable so it can't rub up on the metal, and it's just got a nice little opening there to reach into the main boards. The idea is, like I said, you'll put this top cover on and there'll still be a gap there, so there's plenty of room for the battery to feed through once this is all reassembled. So I've got to put all this back in now, reassemble all the screws and try and realign this whole thing again, which I didn't want to do, but sometimes you just got to do it the proper way instead of making a botched job of it. So I'm going to get this back in. I'm going to get these last 2 boards done. There's not much on them, so I'm just going to finish those up and I'll show you the end results. So here are the final two boards. These are the control boards. The battery is gone. It did do quite a bit more damage than I thought it did. So I had to sort of scrape away all of the trace and re-tin it just to make sure all the corrosion was gone. This is the new battery that's going to replace it. And the general idea is I decided to mount it on the back. I used 2 pins on one side to give it more strength, and then the ground is running off to where the ground used to be. This thing can just be unplugged as needed and replaced. And then we got this other board here which just had 2 caps on it and a couple of films. There's nothing really interesting. So I'm going to get all this back together and we'll close this one out. Alright, so here we are at the finish line. As you can see, it is much happier now. The carnage and the total capacitor count was a lot. These were all the dead ones. I kept them all together because it's good to have some dead capacitors for reference in the future. But yeah, it's a significant amount. We've got all these dodgy MKT films in here, which were bad, and the amount of good capacitors were still in the majority, but it was a lot. This was a lot of work. I know I already said that, but it was a lot of work. All the boards are back in. I'm just letting it warm up, and I'm going to just let it run for a few days and just sort of settle in with all its new components. The battery is all installed in its holder. It's mounted in the corner, and it just runs out and across and straight into that board through a little notch in the frame that I did. So that went really well, nice and clean, which is how I like to keep things. And this metal plate just sort of goes on top and covers everything up again, and the battery just sort of closes in that hole. So that's perfect. We were going to do some amplifier testing in this video, but it's already pushed out too long. There was just too much work to do. So we're going to save it for one final video where we're going to benchmark a few amplifiers and see if this thing gives us useful readings or not. We'll get my load bank set up. We've got some shielded wiring that we've got to make connectors for this. I might do that before the video just so we can go straight to testing because it's just cabling and stuff. But I hope you enjoyed this restoration. It was not something I wanted to do, but here we are. It had to be done, and I got to learn things along the way, which is about all you can ask for when you buy vintage equipment, because you never know what you're walking into. I would say my lesson that I've learned from this overall is don't buy vintage test equipment if there's no service documentation available for it. It's just not worth stuffing around with. If this thing works out great, then awesome, but having nothing to go back to for doing calibrations or references has made this an absolute nightmare. So yeah, that's it for this video, and I will see you in the next one.